Good morning, everyone, and thank you for joining this second webinar for Pixel, which will present you the use cases and the science behind Pixel, which are the models and the algorithms used for this project. I'm Leonidas Pitsikas. I'm a senior project manager for People, and I will present together with Mr. Charles Garnier, who is from Cartier. Now, before we do that, I would like to inform you about some of the technicalities of the Teams application. You can always write some comments if you click on the bubble that is showing the chat of the webinar, or you can raise your hand in case you have any question. Also, before we start, I would like to inform you that this session is being recorded and will be posted online for dissemination purposes. Before I don't think there is a need to make again a presentation of ourselves, because I see that most of us we were also in the previous meeting. So let's start right ahead at the presentations. I'll start and make some, I will present you the participants in Pixel and the participating ports and also their use cases. Can everyone see my screen?
Yes, Leonidas.
Okay. So, catching up from the previous webinars, the ports today face many challenges. The ports needs of today are revolving around the issues of efficiency, environmental sustainability, and smart connectivity. There are some present solutions available, such as terminal operating systems, simulators, port community systems, etc., that satisfy some of these needs. However, although there are information and communication technology solutions aiming at the increase of efficiency and connectedness, these solutions are not focusing too much on the environmental aspect of the port's operation. Pixel, being a European project, formed a consortium involving 4 European ports in order to see their needs. Although they have been presented in the first webinar, let me name them once again, since their assistance is vital to the success of our project. So we have the port of Bordeaux in France, which is one of the ports handling the transatlantic trade in Europe. The port of Monfalcone in Italy, which is now part of the Port Network Authority of the Eastern Adriatic Sea. And this is connected to the intermodal port of SDAG, which is on the border of Italy with Slovenia. Then we have the Thessaloniki, which is the second biggest port in Greece, and which serves also as a gateway for several landlocked countries in the Balkans. And finally, of course, we have Piraeus, which is the biggest port in Greece and one of the biggest ports in Europe. And it is handling most of the trade between Europe and Asia. These are the participating port authorities in the Pixel consortium, and they are providing the use cases we are working to satisfy their specific needs. Now, in the following slides, we will present some of the needs of these ports as they have been formulated during the project course. For the Port of Bordeaux, Pixel aims at assisting the port to meet its local energy needs following the call of a ship in order to cope with the energy production by renewable sources. So they want to do that in order to reduce their environmental footprint. This way they will optimize their available energy resources, and they might reduce their cargo storage needs. The most representative user story of Bordeaux is presented here, which says that as an energy manager, I want to quantify the energy consumption of the port so that I can optimize my available energy resources. Then we have the port of Monfalcone, and the issue here is that Pixel is trying to solve here is that of reducing the bottlenecks and the congestion in port areas, and there are parkings in the route between Esdag and Monfalcone, and also examine the use of rail. During the course of Pixel, these user stories and use cases might have some minor changes, but in general, a summary user story would be that as a port, they want to foresee the possible congestions between the port and SDAG so that they can take appropriate measures. And then we have the port city integration, which is based on the scenarios of the ports of Piraeus and Thessaloniki. The use case is related with the environmental consequences of a port operating inside the city. And their objective is to share information and build synergies between the port, the city, and the transportation actors, and populate this into an online platform, all available information sources for environmental monitoring. More or less, this is all from me. At this point, I'm passing the floor to Charles to present the most interesting part of the webinar, which is the description of the tools that we created in order to satisfy the needs I just show you.
Okay, thanks, Leonidas. Maybe I will share my screen because it would be easier than to change the slide. Okay, I think you can now see my screen.
Yes, we can see it.
Okay, thanks Leonidas for the introduction, and let me first present myself. My name is Charles Garnier, and I'm working in CATI, which is a French technical center, and we do transfer to the SMEs at the regional level. In this project, we were in charge of the work packet 4 of the project that deals with model and predictive algorithm and data analysis. And we have worked with all of the partners of this project in order to develop model and predictive algorithm that are really useful and also based on data available in ports. So let me start with the starting point, and then I will explain what we want to reach with the model and predictive algorithm we have developed in Pixel. So the starting point is that we identified that there is a lack of tools to calculate, estimate, or predict impact on energy consumption, but also on transport network and also on environmental pollution of port activities in small on medium ports. When we are small on medium ports, sometimes it's difficult to use big tools that exist, and the main thing is that we need to have tools that can be used with data ready available in ports and not just a theoretical model. So this is what one of the main points we have in mind when we have developed a model on predictive algorithm. Really develop them based on the data available in ports. And the model on predictive algorithm has also been developed in order to contribute to the optimization of port operation, in order to help ports to also minimize their impact on the environment. So, as Leonidas previously described, all of the models and predictive algorithm have been developed based on the 4 use case that we have in Pixel. So the energy consumption model have been developed based on the Port of Bordeaux use case. the modeling of traffic inside the port have been developed based on Mount Falcon, and the air and noise pollution model have been developed based on the Greek use case. So what we want to achieve with this model, in fact, we want to have a modular and adaptable approach for modeling port activities. We can see Pixel as a tree with the roots as an acquisition layer in which we collect many data coming from multiple sources. Then we have a management layer, and after we have the monitoring and modeling layer, it's the layer we will focus on today, in which we want to convert raw data into useful information about what happened today, but also about what will happen in the future. And then we have the diffusion layer. So let's focus today on this monitoring on modeling layer in the Pixel platform. So we have developed model and predictive algorithm in Pixel. First, we have followed a consistent methodology to model port activities in order to give multicultural results about the port and city environmental management model. And we have also a clear link about the model and predictive algorithm that have been developed in Pixel, and what we've called also the port environmental index. I think the next webinar we will focus on this, and the objective of the models is also to be able to give some raw data to this port environmental index. So we have model prediction on demand of energy, multimodal transport, and environmental pollution, and we want to have interaction also between models. One interaction we have, for example, is the interaction between the energy model and the pollutant emission model, because knowing the energy we consume, we clearly have use this as an input on the pollutant dispersion model. And the main point is that everything is based on ports reality and on the available data in port. So you can see in the figure on the right the links between models and how we have tried to develop models and predictive algorithms. Let me start with give you an overview of the different models components in Pixel. Then I will give you an overview about the predictive algorithm that have been developed. And at the end of my talk, I will focus more on the port activity scenario model in order to just show you how it works and how we can use it in order to obtain, for example, pollutant emission or energy consumption. So let's start with overview of model and predictive algorithm. The first model that have been developed is the one we have called port activities scenario model. The objective here is to be able to model the supply chain and the port activities, because it's the main thing we do in ports. Here we have transition of cargo, and what we want to model here is all the transition of cargo is done in order to be able to then calculate, for example, energy consumption due to this transition, emission of pollutants, how many cargo are entering or leaving the ports. And the objective of these models is to provide a tool that, in fact, give us a list of activities that will happen in a port, and based on this list, we can do many things. So what we need to run this model, we need two things. We need the supply chain description, of course, and we also need the vessel call list in order to know what vessel will arrive next day or next week, and in order to plan the activities that will happen in the ports. The next model is the energy model. In fact, the energy model uses the results of the port activity scenario and use this in order to be able to quantify energy consumption associated to a cargo transition. So what we need is the board planning, the supply chain description on the machine specification, and then we have an energy consumption planning that will help the energy manager of the port to better understand how the energy is consumed when we load or unload a boat. This model can be also coupled with, for example, a photovoltaic production model that can give us some long-term advantage about production, also some short-term prediction. And coupling this two models, we can have an energy balance, and for example, we can have a focus on electricity balance between the electricity produced with a photovoltaic system and the electricity consumed due to transition of cargo. So this tool here is to help ports to better understand how they consume and how they produce energy in order to better plan their energy uses. The next model that have been developed based on the Monfalcon use case. And it's linked with internal multimodal transport, and with the objective to help ports to understand if a different port management and a different internal management can help to reduce congestions. This tool, in fact, acts as a decision support tools to optimize the routing of trucks and help truck driver to know if it's better to wait in the parking area or if they can go to the ports, and knowing if there is some congestion here. So these tools will help the port of Monfalcon to better know what happened, and also to plan some new procedure and in order to reduce the environmental impacts of the traffic inside and outside the ports. Then we have work with the Greek use case in order to know how the emission generated by the supply chain of cargo can have an impact on the port ecosystem and on the city around. For this, we have used and integrate two tools that helps to simulate how the air pollution pollutants are dispersed in the air, and how this can be impact the quality of the air in the city, and also a tool doing the same thing with the noise pollution in order to better understand where the noise is emitted and how it disperses in the port environment. And these two tools are very useful in order to help ports to know how they have to reduce the noise, or they are to place some tools to reduce this. And this can be these are useful tools that can be used by port and small and medium ports to better understand their impact. And the last model was mainly not so developed the other, but it's linked with the water and soil pollution model. For this, we will also use an open source tool and using some 2D approach it's a simple approach, but with a representative geometry using knowing the bathymetry of around the ports. We have a tool here that allow ports to know also how pollutants can be dispersed in water, and all this impact the quality of water around the ports. So for what we call the pixel model, we have developed and work on all of this pixel model, and now I want to show you some predictive algorithm on which we have worked on in the pixel project. The first predictive algorithm is linked with the vessel call prediction, and for this we have used the port database and also the file forms. And using this this kind of data, we are able to predict the vessel call duration, for example, based on this was done on the Port of Bordeaux database, and we are also able to predict a vessel call, so predict some long-term trends in ports. And these two prediction can be very useful for a port manager to also better plan what will happen in the ports. Another predictive algorithm that have been developed in the Pixel project is related with use the AES data and some satellite imagery, and you can show some results in the left, and this is very useful because it can help ports to know the main routes used by vessel. Also identify if a boat is waiting for loading and unloading, if a boat is staying at the berth, and many important information for ports to better understand their ecosystem and how a vessel arrived in their ports. And so this use AES data, and is installed AES receiver in order to obtain this, and the satellite imagery have also be used. Another predictive algorithm that have been developed in Pixel is a predictive algorithm in order to predict the road traffic condition. So this predictive algorithm have been developed based on real traffic data coming from Falcon, Thessaloniki, and Piraeus database. And with this algorithm, we can have some prediction about the traffic volume and average speed around the port, some more advanced prediction about this volume and speed, and also be able to identify traffic congestion. So this kind of tool can be also very useful to port manager, because knowing better how work the port ecosystem, it's easier to plan from the activity of the ports. And the last predictive algorithm that have been developed is linked with the renewable energy production. And here we have developed tools to help ports that have a photovoltaic system installed, in order to be able to predict the short-term production, on knowing, for example, what will be my photovoltaic production in next week, and if we couple this with the energy consumption due to a cargo transition, we have all data we need to have an energy balance and better plan the energy consumption of the world ports. So that's the first part of my talk. just to give you overview around model and predictive algorithm. Maybe you have some question already on this, because then I want to focus on the past model. So if you have question on models and predictive algorithm, please go. I'll be happy to answer.
I see that Mr. Bressele has a question.
Yes, indeed. Thank you. I'm Peter Breslees from Port Expertise. We follow Pixel project from the Docs the Future project, which is closed now. So, but your project goes on. I have a question to Charles. Actually, what we experienced is that some ports refuse to give the most accurate ATA because of legal issues. They say if we claim that this is the correct ETA that we give, for instance, when the ship is to berth at a port area, at a terminal, and the ship is later, then we can be held responsible, for instance, for ordering the port laborers. So the terminal has a cost, and it based it upon the information given by the port. It happens here in Antwerp. The port refuses to give the latest ETAs on vessels. Another topic on ETA is that you have many ETAs. You have ETAs at the pilot station, at the locks, ETAs at the terminal. So it depends on which party is actually looking at the ETA for his own business. If you have to do an inspection, the ship has to be on the berth, for instance. But for a chartered party of a vessel, the ETA at the pilot station is important because normally time begins to count, unless you have exceptions to it. So these are all varieties which actually limit potentially the current solution you have and may need more refining then. Is that correct to your opinion? Or?
Yes, about the different ETA, you have for sure we have different ETA, and if we take the example of the port of Bordeaux, we have also an effect of the tide level on the ETA. So this is something to take care in the prediction. And yes, I've not entered in detail in the ETA prediction. My colleague of XLab can enter on this, but yes, our objective with the predictive algorithm is not to give a result that will be the real result that a port can be used, but just to give tools in order to help port in their planification. And the objective of all the pixel model and predictive algorithm is more to be able to convert the raw data that port have at their disposal into more useful information. And we don't want to have algorithm that take the decision at the place of the port agent or the port operators.
Hi, this is João Costa. Hi, Peter. Thank you for the answer. I'm at XLab and we're developing this. So the ETA that we refer to is the ETA that that relates to the arrival at the dock, and not so much the other ETAs that you mentioned. Is also the ETA that we can calculate with more accuracy from the AIS data that we are feeding the system and the algorithms with, and in a way the ETA that is listed and that is represented in the port community systems. So maybe the first ETA of this kind, and it is related with the AIS data that we get fed with. So AIS data is curated and it's cleaned, and so we try also to clean a lot of the known inaccuracy of that data. That's what we have to work with.
Indeed, some projects consider ETA as a fixed information element, but they lock events to it. So that's why you have different ETAs. So ETA is a whole concept. It starts as soon as the vessel is outside the port area. That's the first ETA, and that's continuously updated. It's just like tracking, tracing of parcel deliveries by special couriers. You can follow the different stages. Indeed, yeah.
And ETA is itself a whole area of research by itself, with tight competition and many great efforts. We have here some quite good ETA for this pixel scenario that then help us optimize some of the information that is here being held. But not but as we are mostly working with port authorities, and this first ETA, it's something that we need, and then definitely a deeper approach could be interesting for further projects, for example, where we develop further some of the functionalities of Pixel.
Okay, thank you.
Thank you very much. Are there any other questions regarding this first part of the presentation by Charles? Okay, Charles, I believe you can continue in the elaboration of the PAS.
Okay. Yeah, so I want to have a zoom now on what we have called the port activity scenario, on how it works and what is the objective of all of this. So the objective is to as I previously said, convert some raw data into actionable knowledge through some elementary transformation of information we have. So in Pixel, we are able to obtain data from IoT sensor, also from some open data API, and for the port IT system. Using this raw data and as an input of the port activity scenario, we are able to then have some outcomes that can be used in different models, and then have them into some actionable information, and display this information into the Pixel dashboard through a notification and alert if needed. So what we need to run this port activity scenario, basically we need two main inputs. The first main input is the vessel call list, and what we have done in Pixel, we have developed some automatic agent in order to retrieve this data, and we need the supply chain description of ports. For this supply chain description, we ask for the sequence of supply chain, and also for the description of the machine specification. And the path model gives results as displayed in the right of the slide, and it gives you the list of activities that will happen in the ports. And based on this list, then we are able to say, okay, we have used this machine during such time, and it consume such amount of energy. And using all of this, we are also able to say, okay, so during the last week or during the next week, we will have an emission of CO2, for example, or NOx pollutant of such an amount. One of the things here is that it could be difficult to have very precise description of supply chain. And one of the main objectives of this port activity scenario model is to allow flexibility to the user. So you can describe the supply chain with a lot of details, describing all the machine, knowing all the throughputs of the consumption or the emission factor linked to a machine. Or you can just describe one generic machine that will be applied to a supply chain. And depending on the precision you have in the input, the outputs of the path model will be scaled, in fact, to the precision of the inputs. So what we want to have this port activity scenario model as a tool that can adapt to the description that a port authority or a port agent or a port operator can insert in the inputs of the supply chain description. The objective of this port activity scenario is also to be able to use it as a what-if scenario. For example, you want to know what will be the impact if you change your crane for a new crane, and what will be the impact of energy consumption or pollutant emission. So you just have to change or to add a new machine and change the supply chain description associated, and then you can run the path model, for example, on all the past year in order to see what is the impact of energy consumption. And so you can use it to play what-if scenario and to explore some future scenario, and also for sure to understand what happened last week and to have an estimation on what will happen in the next week. So as I said, the model outputs adapt to the precision of the inputs, and we let the user freely choose what is its optimal balance between simplicity and a real precise module and description of all the activities. Having this, when you have described your supply chain, you just have to do this one time, and then you can run the path model in a quite automatic way using the Pixel platform, and knowing, for example, every week or every month, what are the consumption the ports have made to load or unload boats, and we can also use this port activity scenario to estimate pollutant emission. And here in Pixel, the pollutant emission will be also used as a basis in order to calculate the port environmental index. So we have also a link with all the goals of the Pixel project. So just to have a look on how we can use this for energy consumption. So we have all the information on data that have been sent to the Pixel platform that are stored in what we call the information hub. So we can use the path to build the list of activities of the ports, and then extract the energy consumption. On the energy consumption, we can extract electricity consumption, fuel consumption, gas consumption, every energy we want on a period of time. And knowing, for example, the electricity consumption, and using the photovoltaic production prediction model, we can have an electricity balance of the ports, and in order to better understand how energy are used, and for example, if it's a good time to store energy, if we have a PV system with batteries, and or if it's a good time to sell the electricity energy. And if we couple the energy consumption with the emission factor associated to machine, then we are able to have a pollutant emission estimation on a period of time, and then also evaluate the pollutant efficiency of the activities, and this give a tools for ports to evaluate the emission related to the cargo transition, and also these inputs are used in the port environmental index that is developed in Pixel, and that will be the next subject of the next webinar. That's all on my side.
If you have any questions, please feel free to ask. As far as I'm concerned, Charles, thank you very much for the presentation. I have a question that is actually something that is related with the ports availability on the data they can give. So how precise the supply chain description should be in the PAS model in order to have results? And are those results connected with the precision of this supply chain description?
Yes, you can. In fact, it's very flexible. You can, if you don't have for example, if you have five crane in your ports, but you don't know the exact specification, you can just use a generic crane and enter a generic description. And if you know all the specification, you can also enter the description of the 5 cranes, and then the pass model automatically able to check, for example, if a crane is available and if it can be used, and all of this is taken into account in the result. So the more you are you can describe the supply chain with a precise specification, the more the results on energy consumption, but also on pollutant emission will be precise. But it's really flexible and adapt to the data you have inside the port.
Thank you very much. Any more questions? Perhaps you would also like to ask regarding the first part of the presentation, or regarding the model's presentation.
One question about your first part, Leonidas. Maybe you can specify how we have track all the port requirements and all the requirements related with use case.
Yes, thank you, Charles. Our colleagues from INCL did a very good job gathering more than 100 requirements, which they categorized into whether they are must-have, or should have, or could have, or would have. And they also categorized them into functional and non-functional and constraints. We kept those requirements, and we transformed them of course, they were taken into account during the development, and they have been transformed into KPIs, which in the pilot cases that we will be running for Pixel in the 4 participating ports, those KPIs will be measured to see if those requirements are met. I see that also Joao has a question. Please, Joao, go ahead.
Yes, I would like to ask Charles regarding this part. With PAS, you can. So my interest here would be how can we play around with the models on the sense of simulation to help planning and so on. So to help the planning department at ports. So I assume that we can have subsections of the pass to say that okay, this area or this functionality of the port will will have this energy balance perspective and this environmental pollution perspective, so that we can somehow see how could we improve the efficiency of the port, both in energy and in environment. Am I right?
Yes, the objective of the pass is to give this kind of result, and also the results the pass give can be divided, for example, per area, per type of machine, per type of energy, per type of cargo, and you can have a lot of filter. And for example, you can check if for bulk cargo you have a good how many energy you use, and for liquid cargo what is the kind of energy you use, and compare all of this, and these are useful to plan and to better understand how you can reduce your energy consumption.
Thank you. And with and I would also be able to, if I'm planning to substitute some fuel, to insert the appropriate information and have some changes, so I could think about what would be the impact of changes that I would do at the ports. So that which is very valuable for the planning departments.
You can play what you call what if scenario, changing the specification of a machine, saying okay, I want to invest in a new machine, but before this I want to compare the energy consumption that I will have this with this new machine. Yeah.
Thank you. That's great.
So thank you very much all for your participation. We're hoping to see you in our next webinar, which will be dedicated in the Port Environmental Index, which is one unique feature of Pixel, we believe, and will take place May or June. Thank you very much all for your attention, and have a good day.
Thank you very much. Bye.
Thank you. Bye.
Thank you very much. Bye. Thank you very much.
Thank you. Bye.